going to be looking at the 15% rule. So why is the 15% rule important in radiology? Well, it helps the technologist to change the technique in order to reduce patient dose. As we talked about earlier in the semester, we always want to use ELERA. So using this 15% rule helps us to adjust our techniques accordingly. Understanding how KVP and mass affect the radiographic image. When we think of KVP, we think of penetration, increased quality, and to a lesser extent, increased quantity. In the past, when we used film screen systems, we looked at KVP as a controlling factor of contrast. But now with technology, we've gone to digital radiography systems, and the contrast is now controlled by the computer software. It adjusts that contrast in the final image. When we think of mass, we always think of quantity. Mass, usually we look at that as density, and that's the degree of darkness for an area on the image. It is important to know that no amount of mass can ever compensate for insufficient KVP. What happens when we increase the KVP by 15%? When we increase our KVP by 15%, but we keep the mass the same, we're actually doubling the overall exposure on the radiographic image. So let's say we have a KVP setting of 6 to 8, and we want to double the overall exposure of our image. What we're going to take is 68, and we're going to times it by 1.15%. The 1 is 100%, the 15 is an additional 15%, and this will give us a new KVP of 78. Now, our calculator will say 78.2, but it's important that you know to round to the nearest whole number. When we look at our control panels, we have whole numbers there, so we don't want to have these 0.2, 0.4, just round the number to the nearest whole. Now that we use the 15% rule, our 68 times 1.58 comes out to 78. There is another way to calculate this, which might be easier for you to use. This way you take the 68 times the 0.15, which is your 15%, and you come up with 10.2. Then you'll just take your 68 again, you'll add that 10.2, and as you can see, we came out with the same calculation of 78.2. So that's our new KVP, 78. Now what happens when we decrease the KVP by 15%? So again, we're going to decrease our KVP, we're going to keep our mass the same, and this way we're reducing the overall exposure of the radiographic image by half. We can use the 68 KVP again. We want to decrease that overall exposure, so we're going to take the 68 times 0.85, which is 85%, and this will give us the new KVP of 58. Again, there's another way we can calculate. Take the 68 times the 0.15, which is your 15%, and again we come with the answer of 10.2 on our calculator. So we're going to take that 68 KVP and we're going to subtract 10.2. So this will give us an answer of 57.8, and we're going to round that again to 58. How do we use the 15% rule to gain an optimal KVP value, but we want to keep the overall exposure the same? So as we discussed earlier, we want to make sure that we use the HAC higher approved optimal KVP values. The goal here is to keep the overall exposure of the radiographic image the same, but we want to adjust the technique in accordance with the 15% rule. So when we do that, we are going to increase the KVP by 15%, and we're going to half the mass. Here's an example problem. We have the original value for a hand radiograph is 55 KVP at 4 mass. When we look at our optimal KVP for a hand, it's 64. In order to keep the density the same, we're going to have to increase the KVP by 15% and half our mass. We're going to take the 55 times the 1.15, and our calculator will come up with 63.25. That will make our new KVP 63. Then we're going to take our mass and we're going to divide it by 2. We're going to half that mass. That'll give us a new mass of 2. The new technique then would be 63 kbp at 2 mass. Or again, we can calculate it differently. We can take the 55 times the 1.15 and we come up with 8.25. Then we'll take the 55 and we'll add the 8.25 to come up with 63.25, or the new kbp of 63. Again, you would just take the mass and you would divide it by 2. Decreasing the mass will decrease patient dose. So remember that patient dose is directly related to mass. Decreasing the mass will always decrease patient dose.